Hello, everyone. Thanks for joining our series of webinars for Hannover Messe 2021, titled AWS for Industrial. In today's session, we've got a whole bunch of presenters lined up to talk about Industry 4.0 acceleration with AWS IoT solutions, again, pre-built solutions from AWS IoT, along with Crowley Carbon, who's one of our solution vendors who got some exciting solution built on top of our Industry 4.0 acceleration we have built before. There are 4 presenters today for the session, starting with me, Pugal Janakiraman. I run the worldwide business development for industrial IoT for AWS, Amazon Web Services. And with that, I'll hand it over to my colleagues to introduce themselves. Prashant.
Yeah, Prashant Adiraju. I sit in the partner organization and focused on building solutions with partners based on AWS IoT.
Hello, my name is Alan Keogh. I'm CEO of Crowley Carbon, and we've been in the energy efficiency business for 10 years and working with Amazon for the last couple of years in delivering energy efficiency and sustainability solutions on the back of Amazon architecture and infrastructure.
My name is Andrei Svirida, and I am a senior IoT solution architect with Amazon Web Services.
Let me go into to talk about Industry 4.0 acceleration solution we have today. Before I go into the actual solution detail, I need to talk about industry trends and what customers are asking for, because Amazon is a customer-obsessed company. Anything we build, it originates with customers, and based on that, we build these solutions. To talk about industry trends, what we are seeing today, one of the most important industry trend for manufacturing industries is data as an enabler. Because manufacturing setup is a brownfield environment, and this setup has been there for the last 2 or 3 decades with PLCs, SCADA devices, RTUs, historians running plants today and generating data for quite some time. But inferring some meaningful value out of data has been always a challenge in manufacturing environment for 2 reasons. One is manufacturing traditionally lacked the compute power to do this kind of big data analytics. And additionally, the technology like AI, ML, and big data analytics are a commercial, out-of-the-box IoT capability has never been there. This was inhibiting these inferences they could have drawn from the data they have been collecting for a few decades. But this has changed now with a whole bunch of solutions available and cloud as an entity providing unlimited compute power. Now you can derive meaningful inferences, which is what customers are trying to do. Once they derive meaningful inferences, customers are hugely interested in Industry 4.0 initiative, because this Industry 4.0 initiative doesn't expect customer to do new hardware investment. It's primarily a data-centric initiative where you learn something from the data, OT data primarily, and then streamline your IT processes or do digitally execute manufacturing processes to streamline your business. Obviously, there are a few other trends happening like product as a service, connected products, things like that, which we all know about it, like connected cars, connected products like vacuum cleaners has been there now in the market. And people are trying to understand these machine-generated data better so they can streamline their manufacturing operations better, plan their inventory better, plan their spare part needs better, things like that. Last but not least, crux of today's presentation is around sustainability solution. A lot of customers are looking for energy-efficient method to go run their manufacturing setup, because a typical plant, a mid-sized to large plant, spends anything from $2 to $6 million annually on an electricity bill. The customer's interest is, can I understand the data from 2 largest consumers of electricity better in the plant floor, which is your machinery running today in the plant floor. Other one is your humidification, ventilation, air conditioning system, to reduce my energy bill. The answer is yes. That's what Alan is going to talk about as a solution which has been built, where you can drive 10 to 20% energy efficiency at a plant floor just by providing data, what you're generating or have been generating for a couple of decades. That's what we are going to talk about. Again, these are the industry trends we are seeing. So the other one is around the value proposition. What is the value customers are seeing around data-driven manufacturing transformation? There is all sorts of numbers here, depending on which industry profile, customer maturity, the use cases, the value around implementing an Industry 4.0 initiative or a data-driven insights. It ranges from anything from 10 to 40% increase in efficiency. Obviously, if you can understand your part performance better and you can drive reuse 18 months, 33 months before the first product is manufactured, there is a much higher efficiency possible. That's why some of the numbers here are talking about 50% improvement product development cost. But these numbers are very much achievable. Again, this comes from our analyst organization like McKinsey and our partners who are doing this work. At the same time, even we are seeing this value proposition. One of the largest initiatives happening today globally around Industry 4.0 is from Volkswagen. It's a joint initiative between Amazon and Volkswagen. Their published number is they are going after 30% improvement in manufacturing efficiency across 120 plus factories and 10,000 plus suppliers. And there is quite a bit of public domain information available from Volkswagen and Amazon Web Services, which talks about how this project is on track today to achieve those numbers. So this is what we are seeing and customers are seeing as value around manufacturing transformation. With that, what have we done, Amazon Web Services? This originated based on multiple requests from our customers. You have multiple elemental services available and also higher level services like Sitewise, which can provide manufacturing insights. But still, there is some amount of work needed for us to go build a total solution linking a hardware to a protocol converter to driving insights with dashboards to integration into manufacturing systems for predictive maintenance, use cases like that. The ask had been, is there a pre-built solution, a ready-made solution which we can configure, start an Industry 4.0 journey in a couple of weeks time frame without investing hundreds of millions of dollars. We listen to customers like that and we build the solution. We call it as Industry 4.0 acceleration. We launched it last year, July. There is a lot of interest in the market. It's a pre-built solution in anything from 4 weeks to an 8-week journey. We can completely build a production-ready solution or a demonstrator where we can ingest data from any type of PLC, SCADA devices in a plant floor, set up a data lake, convert that protocols, multiple protocols with which machine talk to each other on one consistent protocol, and drive inferences associated with that, provide near real-time visibility into data to do root cause analysis, or drive solutions like what Alan is going to talk about, like you can streamline energy efficiency at a plant floor because we already made the data available for Crowley Carbon to consume and drive energy efficiency, or you understand the data better to do predictive maintenance. Every one of these business outcomes are possible day one, instead of taking months to go solve an IT OT problem around connectivity, data, and just setting up hybrid infrastructure between edge and the cloud. We have taken care of all of it. And that's what the solution accelerator is all around. With that, how do you get started? There are 3-pronged approach we take. One is we drive a proof of value, anything from 8 weeks or less, even in fact, if you want to see a solution working in a real plant and a line, which you can identify, and we can configure the solution. And in parallel to that, we can also do a maturity assessment of your multiple plants to roll the solution out and also work on prioritizing what use cases, energy efficiency or predictive maintenance, predictive quality, use cases like that. And then we can build a complete scale-out proposal, which is what we are doing with multiple customers. In fact, we are working closely with Crowley Carbon, a bunch of initiatives today to streamline energy efficiency as one of the business outcomes. And there are multiple other outcomes possible. With that, I'm going to hand it over to Prashant to talk about partner accelerations available today as well.
Thank you, Bhugal. So what I'll do is I'll cover 2 things, right? One is we'll talk about the partner accelerators that we have put in place. And I'll sort of provide a bit of a context of why partners are important in this transformation, right? Bhugal touched upon the business drivers that customers are seeking to modernize their manufacturing operations. So we see more and more companies wanting to do this. And every company is different, right? Some feel comfortable that they can tackle their challenges on their own. They can leverage the foundational services that AWS provides, and they can build on that because they've got the in-house talent. But then you look at other companies, they lack the deep knowledge of the AWS platform. They don't have the expertise to design the right architecture. They don't have the right resources to implement it. And they also lack the technology breadth to integrate with all of their enterprise systems, right? So they need help to, create, whether it is creating simple user interfaces or need help with analyzing all this data. So the approach here is to bring a community of partners across qualified hardware. This is hardware that's qualified to work with AWS IoT services, edge software to essentially help unblock the data or unlock the data from all of the industrial systems. Then you bring this data in so that you can start to achieve meaningful business outcomes, like energy reduction is an outcome we're going to talk about today. The third piece of this is, how do we help customers with a set of expertise to consult, deploy these industrial solutions? Because talked about a three-pronged approach to help customers modernize their operation. The last layer, which we will dive into today a little more, is that top layer that you see is around partner solutions. So this is a set of partners who can essentially deliver a business outcome, a ready-made solution to the customers. So our intent with this ecosystem of partners that we've shown in this image below is to really deliver an end-to-end solution for customers to reduce the complexity of Industry 4.0. And these partners leverage the foundational services AWS brings. They've done additional automation like the industrial machine connectivity quick start, and they build on those capabilities to really deliver what truly differentiates them. And this essentially minimizes the risk. It reduces development costs for customers and truly drives value differentiation. So with that in context, what I'd like to do is talk about the theme today, right? Today we want to talk to you about how we can use the Industry 4.0 accelerator vision that we've laid out here, the set of AWS capabilities and AWS IoT services, and how a partner like Crowley Carbon is helping to deliver on sustainability. Now, I'll make 2 points here, right? If you look at it, 40% of global emissions are from buildings, and a majority of those buildings are manufacturing sites. Now, you cannot get to a net zero without the building being smart or without the manufacturing site being smart, and you have to go digital. So with that in context, I'd like to invite Alan to talk about the solution that Crowley Carbon has built to essentially drive to this vision of how do you reduce energy footprint, how do you get to a sustainable manufacturing operations. Alan?
Great. Thanks for the handover. So what I'll talk to you about today, as teed up by the guys, is how do we deploy these solutions? So we've got the data. What do we do with it, and how can we use the data to drive value, specifically in our case in energy and sustainability solutions? So one of the things we talk to our customers about a lot is, in the world of tech, consumer tech, there's been, people talk about 10x improvements all the time in terms of streaming videos or ordering cabs, etc. But really, there hasn't been a 10x improvement for plant engineers in 30 or 40 years since the advent of PLCs, SCADA systems, and spreadsheets, obviously, as well. Really, the engineers are still using those tools. And, a lot of the time, engineers who are hired to optimize plants and make plants better and drive continuous improvement in energy efficiency and sustainability, they spend their time walking around the plant gathering data as opposed to doing useful work actually optimizing the plant. So really, I suppose what we're all about as part of our solution is to drive that 10x improvement in gathering the data using pre-built solutions with Amazon, our partners in Amazon, to gather the data via the infrastructure that we'll talk about later in the presentation and put that to good use to drive energy efficiency and sustainability. So one of the other things we see is the kind of drudgery of energy reporting or process optimization reporting or production reporting. Lots of spreadsheets, trying to combine production information with energy information, trying to make the two correlate, estimating values because it's 5 days before the end of the month, cutting and pasting information from one spreadsheet to the next and reporting that up to regional, reporting that up to corporate. And the whole cycle takes a long time, up to 30 days or 35 days. So by the time you see something useful in the data, you're looking in the rearview mirror. So that's not obviously optimum in terms of trying to drive energy efficiency and continuous improvement in the plant. So this is our typical solution to gather that data using working with our partners in Amazon Web Services to deliver this architecture. But really, it's trying to fuse the OT world with the IT world as best as we can. So connect into all the dark corners of the plant, dig out data from those dark corners, refrigeration compressors, BMS systems, SCADA systems, electricity meters, steam meters, etc. Pull all that information together, bring it up to the cloud where we can do analytics, but also enhance that information by bringing in information from other sources like lab information systems or ERP systems. Put all that information together so you get the best picture and view of the plant and what's happening in the plant. And from there, we can do more advanced analytics with the data to look for continuous improvement opportunities. So really, the key to our success and driving value for our customers has been that IT solution, so leading edge Industry 4 architecture that we've talked about and we will talk about later, but combining that with real world engineering expertise with real process knowledge, real utilities knowledge, subject matter experts who know refrigeration plants and process optimization and who could build process models for your plant. So combining the data and the architecture and the bleeding edge architecture that we talked about with engineering fundamentals to merge the two together to get the best value. And one of the ways we do this is by distilling down all that complex information and data that we now have into what we call hybrid models. So getting the design and operating data from the plant, then building that into a detailed process model using various process modeling tools, deriving from that a reduced order model, and then using that reduced order model in our platform, which is called Clarity, and populate that model with the live data coming in from the plant. So pressures, temperatures, flow rates, etc. They all go into the model, and then that allows us to then operate models that tell us how the plant it should be operating versus how it actually is operating. So that's what we see on this slide here. So on the top, we have a very complex process, which in this case is a distillation process. So as you can see, lots of pressures and temperatures. We can create a model from that, which is in the green line down below, the optimal steam use line. And for that production run rate and for the vacuums and the temperatures and the conditions that pertained on that particular day, we can then generate a continuous line, which is the target line for the steam consumption of that particular plant, which is the green line. And we can compare that with the actual steam consumption, which is the blue line. And as you can see, there's a delta or difference between the two. And the green line at the bottom tells us the possible savings. So in this case here, it was about a ton of steam or just under a ton of steam potential savings compared to the optimal steam consumption. So what we did in this case here is we worked with the operators and the plant management to optimize that process over a period of a couple of days. So optimize some pressures, temperatures, the vacuums, and we actually managed to get the two lines to converge, the blue line and the green line, which meant the plant is actually operating at its optimal performance, or this particular part of the plant. So this is the power of having the data, bringing it into a powerful platform that runs a model to give you the target line for operating that plant, and all that complex information is distilled down into basically a target for that plant. In this case here, those savings were worth about $200,000 a year. So some other examples of possible opportunities that exist in these plants and using this methodology and the architecture and the infrastructure that we were talking about are these opportunities. And these are all data-led type opportunities as opposed to massive CapEx type opportunities. So we find in a lot of plants, utilities are just ignored. So boilers, air compressors, refrigeration plants sit at the back of the plant or on the roof of the plant or wherever they are. Nobody ever looks at them. Nobody ever connects to them. So pulling that data into a central point, like the Clarity platform that we were talking about, typically generates quite a few savings. So you can do performance optimization and predictive analysis in those utilities. Actually monitoring critical steam users or large steam users. So putting in steam meters, gathering the data and making sure the data is correct and the steam meters are correct, big opportunity. Looking at existing control loops on SCADA and BMS systems, a lot of them are just manual or poorly tuned. So big opportunity to drive energy efficiency. And also just the opportunity cost of manual data collection, tying up engineering resources instead of deploying those engineering resources to optimize the plant as opposed to gather data is a huge opportunity cost. Combining that with detailed mass energy balances like the ones I talked about previously, so that you understand the fundamentals of how the plant operates and the various interactions between different parts of the plant, and then combining that with the hybrid or dynamic KPIs that I talked about. So not just having a static KPI, which is kilowatt hours over production, tons of production. That doesn't take into account all the complexities of the plant. A hybrid model, like I talked about, takes into account all the variables and allows you to know exactly where the plant is operating, how far you are from the optimum. All of those things combined, and they're all data-led type opportunities. Typically, in our experience, for a plant, with $3 million energy spend, adds up to about 100 to 500,000 a year in opportunity in terms of energy efficiency and continuous improvement generally. And just to cap some of that off, this is an example of a customer of ours in the meat processing sector. They have 25 plants in various locations around the world. And they went through this process with us, deployed Clarity, which is our tool, which sits on the top of Amazon's infrastructure, to drive continuous improvement in energy and sustainability. As you can see here, they really see this tool and this methodology as a force multiplier. So they used to be limited to having engineers limited to the factory gate, and now with all the data in their hand, engineers, their best engineers and subject matter experts in refrigeration or whatever it is, can actually look at now 5 plants or 10 plants, and that's what's happening. And those best engineers, the best engineers they have, are now driving efficiency across multiple plants. So that, combined with our expertise to actually take action from the data, not just present nice reports and dashboards, but actually to go on and take action with the data, has delivered them significant improvements in the range of the numbers that Pugar was talking at the start of the presentation, kind of 20–30% energy efficiency on average. So that's enough for me for the moment. I'll hand over to my colleagues to talk about some of the architecture in detail.
Thank you, Alan. Now let's dive a bit deeper into a technical architecture. First, I want to show you an architecture for the pre-built solution Pugal was talking about in the beginning of the presentation. Manufacturers can use this pre-built solution to unblock data from their systems, visualize the data in real time, and perform deeper analytics, and get it production ready only in a matter of weeks. And after that, I want to show you how customers can easily collect and ingest the data from the plant floor into Clarity, a sustainability solution from Crowley Carbon that Alan just presented to us. Speaking about the data, there are various kinds of data on the plant floor available. On this slide, I want to talk specifically on how to process the PLC data. First, the data from individual PLC protocols can be converted to OPC by using protocol converters available from various AWS partners. Then the data travel to the Edge Gateway, which runs AWS IoT Greengrass and Sidewise connector, and can be ingested further for the further processing. Now let's take a look at various use cases which can be implemented on top of this data. First use case is about offering operators and production supervisors an operational metrics dashboard. The Edge Gateway ingests the data into AWS IoT Sidewise, and this is a service which is capable of creating an operational data store for hot data and also modeling the assets and its hierarchies. AWS IoT Sidewise Monitor will access the data from operational data store and visualize them in operational metrics dashboard usable by operators and production supervisors. Another important use case is alarm management. For the purpose of alarm management, data will be forwarded to AWS IoT Events, which is a service capable of detecting events based on the plant floor data. If alarm is detected, Amazon Simple Notification Service will be used to send a notification to operator or production supervisor. Now let's take a look on how customers can build an industrial data lake and which use cases it enables. To build industrial data lake, the raw data can be ingested to Amazon free object storage. Customers can use Amazon EMR and AWS Glue to perform ETL, extraction, transformation, loading processes, resulting in the cleaned and transformed data in the Amazon S3 Silver and Gold object store. And now various use cases are possible on top of the data from the data lake. First, customers can perform machine learning by enabling their data scientists and data engineers to build and optimize their machine learning models using Amazon SageMaker. And additionally, BI reporting of self-service analysis is also possible by loading the data from Industrial Data Lake to Amazon Redshift, which is a data warehousing service from Amazon Web Services, and visualizing this data using Amazon QuickSight. And now I want to mention some additional services, mostly from security and compliance area, key management service, identity and access management service, and CloudTrail. Apart from PLC data, there are two additional kinds of data in the factory. Enterprise data, for example, data from ERP systems, MES systems, flat files, and history files, but also secondary sensor data, which can be basically any sensor you want to retrieve the data from your plant floor. Let's take a closer look to the enterprise data. For example, data from MES and ERP systems. Typically, customers want to achieve two goals using this data. First, they want to load them into the industrial data lake to be able to implement the similar use cases we have seen before on top of this data. And secondly, they want to integrate this data with their legacy applications. They can do so by using Amazon API Gateway, which enables legacy applications to easily access the data from the industrial data lake using REST APIs. Now let's take a look to secondary sensor data. This, for example, can be data from retrofit sensors attached to the machines or any other sensors you deploy in your plant. Many customers want to process this data in near real time and use this data for the similar use cases we already reviewed for the PLCs. To do so, customer can use AWS IoT Core for data ingestion. And based on the data ingested to the AWS IoT Core, they are capable of implementing the same use cases, for example, alarm management, dashboarding, industrial data lake, machine learning, and BI reporting, as we have seen for the PLC data. To summarize what we have seen before, you can use this pre-built solution to unblock the data from your PLCs, your enterprise systems, and your secondary sensors. And this unblocked data can be used to implement operational dashboards, alarm management, industrial data lake, machine learning, and BI reporting, and also integration with your legacy applications. Finally, let's take a look how the unblocked data from PLCs, enterprise system, and secondary sensors can be ingested into the Clarity solution for the purpose of resource optimization. We see that three kinds of integration are possible for that purpose. First, the asset model metadata. These can be static asset attributes like serial number, but also, for example, telemetry attributes. They can be retrieved from AWS IoT Sitewise and loaded into the Clarity solution. Secondly, the near real-time telemetry data from PLCs and other IoT devices can be ingested to Clarity by using MQTT broker of AWS IoT Core. And finally, also the integration between industrial data lake and Clarity solution is possible. In all three kinds of integrations, customer can use AWS Identity and Access Management to perform a fine granular control of which data are allowed to be ingested into the Clarity solution. Thanks so far for your attention, and handing over back to Pugal.
Thanks, Andre. To wrap up this presentation and quickly summarize, as Andre pointed out in detail on the solution architecture we have, this is a pre-built solution. This is not an elemental service where you have to go write software to build an Industry 4.0 solution framework to drive business outcomes like energy optimization. It's pre-built. We can configure it in a matter of few weeks and then get a solution out there, whether it is energy optimization, which Alan talked about, which is of a lot of interest for our manufacturing customers, or do predictive maintenance or predictive quality. We can drive those business outcomes day one with a business framework and a solution offering we have provided. And with that, thanks for attending the session. Looking forward to people who are going to reach out to us on this front. If you have any questions, thanks again.